Hi, everyone. So, first of all, thank you all for being here today. For me, it's a special pleasure to be here because, long story on my family, they came from Italy, they immigrated to Brazil, and this is the first time I'm here in Italy on a stage talking, so it's a pleasure for me to be here. Yeah. And today I'm sharing here the stage with Luciano, and we'll be talking a bit about how can we build multi-tenant SaaS applications using the serverless components in AWS. Just before we start, let me start by, if it works. Hello?
Too far away. I can do it for you.
Yeah, thank you, Luciano. So let me just introduce myself. My name is Guilherme. As I said, I'm from Brazil, but currently living in London, and I'm the CTO of a startup called MerCloud. I've been for quite a while in the industry, and we lost that again. This is when you start realizing how old you're getting when you look at those numbers, but a big achievement that I recently had was becoming a part of the AWS Community Builder group. And if you'd like to follow me, get in touch, these are my links. And just before I hand over to, am I pressing, oh yeah, I was pressing the wrong button. Oh, thank you. Yeah. So just a bit about MerCloud, what we do. So we're a startup and we build an e-commerce platform that specializes on the B2B market. For you to understand a bit what is that, think about Shopify, but to handle transactions, sales between the enterprises on the supply chain. So from when you get to the supplier all the way back to the retailer. So our platform is specializing in handling this kind of transactions. They are high volume because companies here, they are building from each other in order to refill their stock. So we built a specialized platform around that. If you'd like to know a bit more about this company or maybe check if we have any openings, that's the link over there. So you can reach out to us. I'll pass the ball to Luciano.
Thank you, Gil.
It's not working.
Okay, go next.
I'm trying.
Okay,
There you are.
Yeah. Now, so thank you, Gil. Hello, everyone. My name is Luciano. I am an AWS Serverless hero. I am the co-author of these two books that maybe you have seen, maybe not. So you can tell that I'm especially into Node.js and Rust. So if you're actually curious about how to write Lambda functions using Rust, which I think is a great idea, of course, check out this book. Let's get into the topic, but actually, before I want to quickly tell you about the company that I work for, it's called Theorem. We are a consulting company. We help our customers to be successful with AWS, which means doing all sorts of kind of things from like cloud migration, training. We have some interesting use cases like building high-performance serverless application for the financial industry especially, and also doing things like cloud cost optimizations. And one thing that I'm especially proud is that we do a lot of activities around creating content and sharing knowledge. So we also have a podcast. So if you're curious to know the things that we do and the things that we learn and we want to share, check out AWS Bytes at awsbytes.com. Okay, so let's start the topic finally. Finally, we're done with the introductions. So let's start to talk about what is a multi-tenant architecture. And if you look online, there are like hundreds of different definitions. So let's try to agree on one that is going to be working for today. So I would like to define a multi-tenant architecture as a software architecture where you have some software that you are deploying, and it doesn't matter if you deploy to just one server or multiple servers, if you have a microservice architecture, if you have a monolith, that doesn't really matter. What matters is that you have one unit of deployment, you deploy that unit, and that unit is serving multiple customers that we generally call them tenants. Now, the reason why this is important, this is something that we are talking more and more for the last decade probably, is that by doing multi-tenant applications or multi-tenant architectures, we are trying to optimize as much as possible for cloud consumption. So we try to be as efficient as possible in using the resources that the cloud is giving us to serve our customers. So that generally means that you can be more efficient and you can have better margin when you are selling a service or a product. because then you are trying to share as much of that resources among multiple customers. So when we talk about tenancy, of course, we have two opposites. Today, we're going to be talking about multi-tenant, but I think it's worth also understanding a bit more what multi-tenant means by looking at the opposite of it, which is like single tenant. And if you look at this diagram here, you can see that in single tenant applications, you have, for instance, here we have 3 different tenants, and you have 3 totally isolated stacks. So you have here the application and the database that are totally isolated from the application and the database of this other customer, and so on. Instead, with a multi-tenant model, which is what we are going to be talking about today, the lines are a little bit blurred. You don't necessarily have to share everything, but as you can see here, 3 different customers, they actually share the same application level. They don't necessarily have to share the database, and this is where we get into isolation strategies for multi-tenant applications. So there are different approaches that you can take. Sometimes it's better, for instance, for compliance reasons, to go at the extreme right of the screen, or your left of the screen, which is basically the silo model. And this model is basically when, even if you have the same shared application layer, you keep the database separate. So every tenant has its own database. Then there is an approach that is a little bit of an hybrid that is generally called the bridge approach. And you can do something like this, for instance, if you're using a data storage like Postgres, where you have a database server, but within that server you can create isolated schemas. Inside the schema you have all the tables for a specific tenant, and this is how you reuse the same database server, but you still keep the data somewhat isolated. And then you have the more extreme model, which is called the pool model, where you are effectively trying to share as much as possible. So you have one database server, one schema. Inside that schema, you have multiple tables, but inside those tables, you are mixing data from all the different tenants. So, of course, it's especially important that for every record, you have something like a tenant ID that allows you to tell, well, which record am I looking at, which tenant does it belongs to, right? And, of course, these strategies that I just talked about, they are not necessarily like a black and white choice. Often enough, in production, you end up with a mix of these different strategies, because in reality, you always have like a huge majority of your customers, generally like more than 80%, which you can call them like the average customers or the regular customers, which they all kind of have the same kind of consumption patterns. They would want certain features, but they are all similar between each other. Then you have kind of the special customers, what you could call like the premium tier. So these are probably the highest paying customers, but they are also more demanding. They're going to be using your platform more. They're going to be asking for special features. They might have like stricter compliance requirements. So generally what happens is that you end up creating an architecture where you can put all the average customers in one place and you try to share as much as possible. But also you want to support the premium customers, and for them you might have like more reserved distances, more isolated data, and we'll see some examples of that. So just to summarize everything I just said, the benefits of a multi-tenant architecture, the first one is probably cost efficient, so we want to use the cloud resources in the most efficient possible way, so wherever we can share resources, we should try to do that. The other one is scalability, because generally, if you're thinking like the most isolated possible model, so the single tenant model, that model means every time you get a new customer, you have to deploy an entire new stack. So effectively, you are scaling your architecture, your infrastructure, like one by one. Every new customer means multiplying everything by the number of customers, which is, it can work, but of course, it's not going to give you an economy of scale. When you start to share things, the cost of growing your infrastructure is sublinear compared to the cost of growing your customers. So the more customers, effectively, the more efficient your cloud deployment becomes from a cost-saving perspective. And sometimes that also comes with simplified management, because thinking about a multi-tenant architecture forces you to think about how do I create standard pipelines? How do I quickly onboard new customers? How do I make sure that every customer I onboard, they have a consistent experience? So that generally forces you to create like a management layer or a data plane or a control plane, whatever you want to call it, that standardize all your processes around managing customers and tenants. And that also comes from a security and compliance perspective, because you can enforce policies that you know they are going to apply for all the customers. There aren't like snowflakes or special deployments. From a productivity perspective, developers are generally working on a single code base, so that can make them more productive. And also from a business agility perspective, every time you are thinking about a new feature, you don't have to think, oh, which code base do we have for this customer? Can we deploy that feature there? Or is there something different there that kind of breaks and we need to make like a special case? You have one code base, you put all the features in that code base, and then if you want, you can use something like feature flag to enable, disable these features for different users. Okay, let's see if this works. So let's get a little bit into the meat of the talk. So we want to talk about serverless on AWS. How can we build multi-tenant applications using some of the serverless tools that we know and love? And I'm just going to give you some details. I'm sure, for instance, everyone is familiar with API Gateway here. What I want to mention here is that aside from the fact that always annoys me that we have REST and HTTP, and they are kind of similar but also different enough that it's always painful to figure out which one do I use and which feature am I going to have. Let's leave that rant for the after party. So what I want to say today is that one cool feature that you have with API Gateway is authorizers. So there are some built-in authorizers, for instance, IAM, Cognito, and JWT. But the cool thing is that you can also build the custom ones, and today we are going to be working a lot with custom authorizers. So what is a custom Lambda authorizer? It's effectively a Lambda function that you can write to specify your own bespoke authentication or authorization logic, put it together working with API Gateway, and then effectively what happens is that a request coming in, you need to validate if that request is authorized to go and talk with the backend. API Gateway is going to call your custom Lambda. You run your own custom logic and decide, looking at the request, what am I going to do? In our particular case, we are going to be using Cognito as well, which I'm going to be talking about in a second. The idea is that your users are going to send you requests with tokens. Inside the token, you're going to have to extrapolate the tenant information. So through the token, you know this request belongs to a specific tenant. What is Cognito? If people haven't heard of Cognito, you can think about, I don't know, Auth0, Okta, Clerk, all of these services doing user management and authentication. Cognito is effectively the AWS version of that. So it's a managed service for users and authentication. When you use Cognito, you can also think about like a storage layer in a way, because of course you are storing all the user information and the tenant information. So you can also apply all the logic we described before. Like, do you want to have a user pool, and a user pool is like a table with all the users inside? Or do you want to have multiple user pools, like one per tenant? And again, you can also have an hybrid approach where you can say, well, all my average customers, they're going to be sharing one user pool, but I have premium customers, and they're going to have their own dedicated user pools for more isolation. The important thing is that whatever you decide to do, it's very important to have a process, define it up front, have very clear rules, and hopefully have like playbooks, maybe automation as well, that you can put in place to make sure that when you get a new customer, all the onboarding is done correctly. Okay, now let's look into a real, well, somewhat real use case. Imagine that you have a user, the user needs to talk with your application. What happens behind the scenes? So the first thing that the user needs to do is, of course, get a token. So the user is going to do some kind of authentication. Generally, we can think about username and password. And this is happening talking with Cognito. And what happens, oops, if the screen works, okay, next slide, cool. Yeah. So we get a cool username and a cool password that goes into Cognito. Cognito is going to evaluate if this information is correct. And if it is, it's going to say, okay, you are who you say you are. I trust this information. I'm going to give you a token that identifies your current session with the system. Now, I'm not going to spend too much time talking about JWT, even though I would love to do that, to the point that I even wrote several articles. This is one of them. But the only thing you need to know about JWT, JSON Web Token, is that it is something that looks like a random string, but it's not really a random string. It's actually a string that contains information. And there are two important parts to this string. One is where you find the claims. You can think of that as a key value pairs that contains things like the username, the user email, the tenant ID. But then there is another part, which is a cryptographic signature that you can use at the backend level to verify that that token is actually authentic. So it's coming from a source that you trust. And if you trust it, you can read the claims and use them for authentication and authorization. So at this point, the user has a token, and every request that the user is making to API Gateway contains that token to identify the current session. So API Gateway at this point can use that token, validate if the signature looks authentic, and if it does, it can decide this request is authorized, it's going to go to the backend does whatever it needs to do, and the response is propagated back to the user. Now, all of this is hopefully relatively straightforward. I'm sure you have seen something like this in different applications. Let's make it a little bit more complicated. Let's introduce two users at the same time, but they belong to two different tenants. So user 1 and user 2, they belong to tenant 1 and tenant 2. They are both authenticated. They have their own JWT. They can make requests. And every time they make a request, it goes through API Gateway. API Gateway is using the custom authorizer to make sure that they are effectively authenticated with a valid token. If the authorizer says, OK, you can proceed, the two requests are forwarded independently to the backend. And this is where effectively something interesting starts to happen, because probably that Lambda needs to interact with some kind of storage, maybe like a DynamoDB table for records, maybe an S3 bucket for attachments. And this is where you are probably partitioning your tenant data in some way, and you need to be extremely sure that you are not leaking information between tenants. For instance, that same Lambda can access data for tenant 1 and tenant 2, but what happens if the Lambda returns data to the user 1, but that actually belongs to the tenant 2? So this is where effectively we are leaking information. And that's why I like to call this the danger zone. Sorry, Massimo, I'm stealing the danger zone. Because this is where you need to be extremely careful. If you have a bug there, something really, really bad can happen. And this is an event that can even bankrupt companies. Imagine if you are in healthcare or the financial industry, you don't want anything bad like that to happen. But to really understand why this is a problem, let's do a little bit of a step back. And let's try to think, even without thinking about multi-tenant architecture, what is the permission model that we use in AWS when we use Lambda, for instance, and DynamoDB in this case? So if you want to tell a Lambda, you are allowed to read, for instance, from a DynamoDB table. How do you do that? How do you make it happen? So generally, the way we do it, if we do infrastructure as code, we create a definition of the Lambda, and then in that definition of the Lambda, we also attach a policy. And a policy is effectively a JSON document that says, OK, this Lambda can actually do two things. It can do get item and query on this specific resource, which is a very specific DynamoDB table. And of course, here what we want is to be as restrictive as possible. So we want to give the least amount of permissions that are needed for that Lambda to do its job. Then the next step is that basically at runtime, when that Lambda is running, you probably need to do queries. So you need a few things. First of all, you need a DynamoDB client. And notice here that we are not passing any extra configuration. We are not passing credentials. So what happens by default is that that client is going to look at the current environment, so the Lambda environment. So when a Lambda environment is created, using the policy that we defined before, there is an execution role that can only perform the actions that we defined in that policy. And that execution role has temporary credentials attached to it. So this client is effectively borrowing those credentials automatically. So this client can only perform the DynamoDB actions that we defined in the previous policy. But this is where we start to see the problem, because at some point we need to make a query, and this query is going to have a variable. For instance, here we have tenant. This is like the tenant ID. And this is where things can go wrong, because what happens if this is user 1, but this variable, for whatever reason, can be a vulnerability, like an injection, or can be just a bug that we introduce in our code. So user 1, what happens if this is tenant 2? This is where we are going to be leaking data to the user, seeing data that it shouldn't be able to see. So the question that we have today is there a better way where maybe the infrastructure can somehow enforce certain policies that even if we have a bug or a security issue, when this kind of issue can materialize, maybe the infrastructure will stop it from happening. So we can put extra safeguards that will protect us from having this kind of issues and then leaking data to the wrong tenants. So Gil, I'll leave it to you to explain this amazing solution.
Thank you very much, Luciano. So like Luciano said, and we could notice, we have the danger zone here. And one of the problems of this danger zone is that we're delegating too much responsibility for this single Lambda. So we want to find a way where we can delegate this to somewhere else in the platform and reduce the scope of it. So it does only what it's supposed to do, to go to the database and collect that data. It doesn't need to handle authentication, authorization, anything else. And where we planning to, yeah. So we'll be looking how we can delegate that to someone that comes before that on the flow. And we'll be looking particular at the Lambda authorizer that we saw that is behind API gateway, and API gateway will be calling that to authorize that particular request for us. Finally, let's see some code here. So how the code of that authorizer would look like. Yeah. So the first thing we need to do here is to validate that token that's coming in. So here, we're assuming that this token comes through the request headers, the authorization token. And then what's going on behind the scenes on this particular function here, it's going to Cognito, and it's going to pull the public keys from that. If you know a bit about the OpenID protocol, it usually comes from a well-known location. And that endpoint returns something like this. It's a list of all available public keys that are used to sign those tokens. And then what that function needs to do is to find what public key relates to that token, and then you validate the signature of that token. And then if the signature is okay, so we can assume that that token, it's a valid token, and we can assume that the claims, like who they are saying they are. I can trust that. So from that one, I can simply read those claims and don't worry about if they're valid or not. The second part is where we're going to be assuming a particular role that we created as part of our infrastructure. And this is a custom role we created, and we'll be looking at two particular things here. First is a statement where we're restricting who can assume that role. And here we're saying that only this authorizer Lambda can assume, no one else in the platform can be using this role. And the second part is where we'll be defining the policies of this role. So think about the policies is like the boundaries. What anyone assuming this role using these credentials can do or cannot do in the platform. And here on this example, we're saying that they can do any read or write operations in any of the Dynamo, it's very hidden here in the corner, but on any DynamoDB table from this stack. So we're assuming this. So think about this policy. If it's not listed here, you cannot go beyond. You cannot do any other operation that's not listed here. And then when we're assuming a role, the next step, we actually defining an inline policy. And here we're refining those boundaries, and we're scoping it down to this particular session. So here we'll be saying, okay, for this particular session, you can only do a query on this particular DynamoDB table. This is the place where we put actually some logic into it. For example, you'll be looking, what's the role of this user? Is the user an admin or not? Can he perform something else? And then you'll be playing with these actions and resources, and you'll be adding more or less privilege to it. And second, we'll be defining a condition here. We'll say, okay, you can access this DynamoDB table, but you can only access records records from that they belong to a particular tenant. So when we're structuring our table, we set a partition key, and the partition key there is the tenant ID. And here what we're saying, okay, you can only access the records that they belong to that partition key. Yeah, and the value here is coming from a tag. Okay, the tag we also define there when we're assuming the role. So the name of the tag is up to you. You define how you want. And the value is the tenant identification that we extracted from the token that we validated. Yeah. From there on, we need to return to API Gateway a policy that says, okay, what can you access? What can you do on an API level? And here we're saying, okay, you can do a GET request on the slash path. That's it. That's all you can do. Yeah? Then we return that. And on the return statement, we end up adding an extra key there that is a context. So this is a place that API Gateway allows us to put extra information. Think about metadata. And this information will be forwarded to the upstream services. And here we're setting two important keys here. First is the tenant ID that we extract from the token. So from now on, every time I need to find what the tenant ID for that particular session is, I don't need to decode the token anymore. I just read that from the context on my Lambda. Yeah? And then we're setting the credentials. So I assume the role. When I assume the role, I get credentials. So my Lambdas will be using those credentials to connect to DynamoDB, S3, any other service. It's a lot of things, so let's just do a quick recap here so we don't get lost. So we created a policy. That policy has those well-defined boundaries, and we restricted who can actually assume it. And then we assume a role, and then on this role, we scope down the policies from it. It's just a subset of the boundaries of our main role, and we tag the session. Then we build the policy for the authorizer, and then we return that metadata with the information. And the most important information there is the credentials that we just generated from assuming that role. But why do we really need to assume a role? As Luciano showed us with an example there, the execution role we get on our Lambdas, they are quite generic, and we cannot really trust them much. And also, we don't have much control of that. Here we saw an example where we're setting an inline policy, we're setting a condition. We don't have all this, we cannot do that on the default one on the Lambda. So we're taking that out from the Lambda, and we delegate into the authorizer. Yeah, so we can ensure that any credentials that we get to the Lambda, they are fine-grained, and they have that special condition key. Let's look at our flow again. So the user will be making the request to the API gateway, sending the token. The authorizer will assume that role, validate the token, and then return all this information back to API gateway. Then API gateway will call our backend Lambda, sending those credentials that we set on the context, and plus the user and tenant information. And then, if everything is OK, then our Lambda will be using those credentials to query DynamoDB. Everything is fine. Now, let's assume that there's an exploit or a bug in our code, and this Lambda tries to access data from tenant 2. Then the platform itself will deny that request. You say, OK, these credentials are not allowed to access these records inside this table. So we took out that responsibility away from the Lambda, and the platform is dealing that for us. Cool. We're covering a lot DynamoDB here on these examples, but what if I'm working with other services? Yeah, can I do the same thing there? Yes, you can. For example, if you're trying to access something on S3 or Cloud Search, you can do something very similar, but then you'll be restricting the keys and, for example, the index, the collection IDs on your Cloud Search. You can do this kind of restrictions. And if you're using Aurora with the Postgres flavor, you can do that as well. The only gotcha there is that you'll be working with row-level security. That's a Postgres feature. I'll be back in a second. And what if I'm doing anything else, right? I went one over. Oh, spoil. Sorry. Yeah. So you're pretty much on your own. So you either need to use separate instance, one per tenant, and what's gonna be the key decision maker there is like the kind of compliance and the requirements you have, or you either do code-based checks, like your if on your code to set the tenant. So yes, you're on your own. Cool. When we're talking about SaaS and multi-tenant, something important also that we need to look at is how, just a step back, before we try to share as much as possible through all the tenants, we need to find a way where we can prevent some tenants from abusing the system and making the overall performance of the system be bad for other tenants that then have nothing to do with that. Right? So how can we create a mechanism that will handle that for us? So API Gateway has two features that can help us with that. One is API keys and usage plans. So we can we can define like rate limiting policies and assign that for each of our tenants. And we'll be looking at that. So this is how our structure looks like. The users, they keep sending the request to API Gateway. It goes to the authorizer, but now we're adding a new component to this stack. That's a DynamoDB table. It's a very single table. It has a key value there. And where we store each tenant, what API key belongs to it. So this API key you generate through API Gateway. Yeah? And we set this as part of our onboarding process. So when I'm creating a new tenant, I generate a key and assign to it on this table. So my authorizer now, at the end, needs to do one extra step, fetching the key for this particular tenant, and then returning back to the API Gateway. From now on, API Gateway will be handling those limits we set for us. We don't need to do any more configuration. So if it needs to be doing throttling or reject a request because of rate limiting, we'll be doing that automatically for us. In terms of code, so everything we saw on the authorizer before, we have one extra step here. So we'll be doing a get on the DynamoDB table. And then we'll be using this special key on the return of the function that will be sending back to API Gateway that API key that we generated. This is not a very well-known and well-documented. Not everyone knows about that, but this is how API Gateway works. OK. And I'm a multi-tenant platform. Of course, I have different personas. Each of my tenants, they come with different requirements. Some tenants, they will require way more throughput than others. So how can I handle this? From what I see here is a very generic approach. So why if I need to give way more throughput to one tenant and not to the other ones? So here's where we can use the usage plans. Also a feature from API Gateway. You create a usage plans, you set all the limits from them, and then you assign them to your particular tenants. Quick wrap up here. So yeah, we can build multi-tenant architecture in AWS using the serverless components, and they have features that they help us to build everything we need. We don't need to reinvent the wheel anywhere here. We just need to be very careful on how we access this data for compliance reasons. Like Luciano mentioned, depends on the business you are, that can completely bankrupt you. And observability here is a must, right? Why? You need to know who is using those resources and how much of those resources they're using in order for you to identify where the bottleneck is. Yeah? There's a very good video available on YouTube from re:Invent a couple of years ago. They cover a lot on this topic. We highly recommend if you want to watch that one. And all the code you saw here, we have it shared on this repo. Luciano and myself, we contributed to that. It's open source. If you want to contribute or you just want to use as a template for something you're building, please check that. And we got some additional resources here as well. Just a shout out to the Well Architect Framework. They have a whole topic there on SaaS, and also to the SaaS Factory project that he helped us to build this talk. Thank you very much. So we really appreciate the feedback. And if you want the slides, they're available here. You can access the slides. Thank you.